So this is Slera, which is the sign language emulating robotic assistant. Startup is initialized by a motion sensor that we just had to calibrate. So it'll wave the hands. If you heard that, it said, "I am Slera." Alright, so here we have our main menu screen where it has our letters along the top row, and then it has an arrow on the bottom that points to each letter. And you can move the arrow to letters with this potentiometer dial. It'll move to each letter. So we have more letters than we have for our 16-digit LCD or 16-character LCD. So we actually have a second screen. If you scroll all the way over to the right, it will automatically update to this second screen, where it has just another letter and some special characters. So if you go to a letter and press this interrupt button, it will basically set the variables, tell the motors to go, and have our voice synthesizer say the letter. So let's start with D. This is D. This is what the thing will do. It says running on the LCD. There you go. Here's E. Alright, and so M and N were a little tricky because M is like this, while M is this. It's just difference in the thumb. And our thumb doesn't quite have that much motion. So we just simulated that with the fingers going down at different times. If you go to M, this finger will go down first, the pinky finger, and then it'll bring the other three down. And M, pinky and ring finger will go down first to show the difference in those. So, and here's our favorite special character, special gesture.
So the circuitry is actually not all that complex, surprisingly. We have a 9-volt, 1-amp wall transformer running the logic on both the breadboard and our SSC servo controller. And then we have a 5-volt, 3.7-amp wall transformer running all of the servo motors, because initially we ran into problems with not having enough current, and we'd actually drop the voltage and ended up resetting our servo controller whenever we were trying to move the servo. But with 3.7 amps, we had plenty to run all of them at once. And then our pick is a 16F917, which is a 40-pin pick with a 10-bit A to D built-in digital converter, analog to digital converter, which we used for our potentiometer rather than using the pot command because we found that to be a little bit flaky. The pick is integrated serially. It communicates with the SSC and our SpeakJet DIP. The SpeakJet is our digital voice synthesizer. It simply strings together sounds to emulate human voice, and the output of that goes to a transistor to give enough boost to run our speaker to reasonable volume. The PIR, our infrared sensor that we use to turn on and off the device, is simply run with a 5-volt ground and data cord. So whenever it senses motion, it goes high to the pick, telling it to turn on or stay on. And if it doesn't sense motion for over 20 seconds, we have it set to turn off.
We've got just fishing lines strung down to the motors to create tension on different members of the finger. There's a cable that runs up the back of the finger to pull them all up, and then a cable that runs on the front of the finger to pull them all down. And then the thumb was special. It has 2 degrees of freedom, so we got just basically a cable to rotate it and a cable to pull it in and out.
Those cables are on the servos. They're 180 degrees apart. So if we turn the servo, we can just use one servo to turn each finger up and down.
This is our SSC 32 servo controller, which we have our 6 servos run into. And then right back here behind our PIC 16F917, we have our SpeakJet digital voice synthesizer. The can is actually just a Red Bull can that we turned into a heat sink to solder onto the top of our transistor because we had issues with it getting too hot because we used too low a resistance.